Here we are going to understand the square wave voltage inverter principle. This is a simplified circuit of an inverter using 4 switches. 5 volts DC source is used as input. Let's turn on S1 and S2. It will create positive 5 volts at output. Then turn off S1 and S2. Turn on S3 and S4. Then the output becomes minus 5 volts. Repeat the same switching sequence again and again. Let's check the output voltage waveform. The circuit is generating nearly sinusoidal AC output. We can see the square wave shape due to addition of odd harmonics to the fundamental. We can analyze the waveform using Fourier series. Now we are going to simulate our circuit using MATLAB. Open Simulink in MATLAB. Create a blank model. Always remember to save your work. Use the underscore symbol in file name rather than space. Now we are going to build our Simulink model. First open the Simulink library. Number 1, search IGBT and add IGBT/diode. Search DC voltage source and add. Search RLC and add RLC series branch. Search scope in search bar. Add scope, from, and go to blocks to the model. Search voltage measurement and add voltage measurement block. Search current measurement. Add current measurement block. Search pulse. Add pulse generator block. Let's go to implementation of the circuit. Create 4 copies of IGBT block. Keep the 4 copies. Delete the original one. Arrange them in 1 3 4 2 order. Complete the paths. Create 2 copies of RLC series branch. Now we are use measurement blocks for voltage and current measurements. Complete circuit for input voltage and current measurements. Using from and go to blocks, we can send the voltage and current signals to the scopes. Use exactly same name for the two blocks. Connect ARL load to the IGBT bridge. Select the measurement blocks like this. We can create a new block called as subsystem. Let's configure the subsystem. Arrange the components as you need. Rename the output and input connection with meaningful names. Rename the subsystem with a meaningful name. We can use a copy of the subsystem for output measurement. No need to implement it again. This is an application of subsystem. I made a mistake before. Please interchange V and I of the labels. We don't need these stuff. Remove them. Search logical operator. Add logical operator block and convert into a NOT operator. Connect logic signal to the gates of IGBT1 and IGBT2. Connect inverted logic signal to the IGBT3 and IGBT4. Now we are going to create a new subsystem for IGBT bridge. It will have two inputs from the source, two output for the load, one input for the gate pulse. Delete the unwanted connections. Properly arrange remain connections and rename them meaningfully. Rename the subsystem as IGBT bridge. We will use it on next video as well. Change scope parameter to see the input and output both measurement on the same scope. Configure both voltage and current measurements. For a 50 Hz output, we have to configure pulse generator parameters. Use period value as 0.02 seconds. We know that 1 divided by frequency is the period. Change pulse width as 50%. Now we can visualize pulse signal using a scope. Save and run the module. There is a problem. You can see there is no graph in the simulation. Let's change the simulation duration and run again. In order to get a solution for an electrical system in Simulink, we need to add a solver to solve the system. Add Power GUI block to solve the electrical system. Let's run the model again. Now we have the simulated output of the pulse generator. Let's configure input and output of the scopes to get a better visualization. These are the input voltage and output voltage waveforms. Input voltage have a voltage ripple at each cycle when output changes. This is due to sudden draw of current from the source. By changing the capacitor value to a higher value, we can reduce the voltage ripple. Subscribe, Curioza channel. To get notifications, click the bell icon. Thank you for watching.